Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. So in this video, I would like to explain the different methods of solutions of ordinary differential equations. In the previous video, we have done the variable separable method and how to solve the homogeneous differential equations for first order and first degree equations, and already we have solved the non-homogeneous differential equations also in the previous video. And in this video we will do one example on non-homogeneous differential equation. Already I have explained in the previous video the non-homogeneous differential equations are of the type dy by dx is equal to a1x plus b1y plus c1 by a2x plus b2y plus c2. So to solve these equations, we consider two cases. If a1 b2 minus a2 b1 not equal to 0, we follow one method. If a1 b2 minus a2 b1 is equal to 0, we follow another method. So already we have seen the working principle, how to solve the differential equation when the cases are arises. Now we will see another problem, that is comes under case 2. If a1 b2 minus a2 b1 is equal to 0, how the equation will be solved, that will we see in this video. So here the given problem is see the third problem. This is the differential equation. Here is dy by dx is equal to, I can write this as 4x plus 6y plus 5 by 2x plus 3y plus 4. I am solving the problem number 3, and clearly this is in the form dy by dx is equal to a1x plus b1y plus c1 by a2x plus b2y plus c2. Clearly it is a non-homogeneous differential equation. So first we have to check the condition. Here a1 is equal to 4, a1x, and b1 is equal to 6. And what is a2 here? a2 is 2 and b2 is 3. Now we check the condition a1 b2 minus a2 b1 is equal to 0 or non-zero. So a1 is equal to 4 and b2 3 minus a2 2 and b1 6. Here the value is 12 minus 12. This is equal to 0. That means the problem solution comes under case number 2. So if a1 b2 minus a2 b1 is equal to 0, then the numerator, this term or the denominator term, may be expressed in the other terms. So now I can write 4x plus 6y as 2 into 2x plus 3y. I can write the denominator 2x plus 3y as it is. The numerator part I am writing 2 into 2x plus 3y. Then the new equation becomes, how I can write? I will write dy by dx is equal to 2 into 2x plus 3y, I see the constant plus 5 by 2x plus 3y, and the constant as it is, whatever you have, that is plus 4 here, this is plus 4, that I am writing as it is here, because a1 b2 minus a2 b1 is equal to 0. If not equal to 0, we go for another procedure. If it is equal to 0, then we can express either numerator or denominator as in terms of other numerator or denominator. So now to solve this problem, we take the substitution, put 2x plus 3y is equal to some other variable t. Then on differentiating this with respect to x, we get 2 plus 3 into, on differentiating with respect to x, dy by dx is equal to, this value is dt by dx. Or what I can write is dy by dx is equal to 1 by 3 into dt by dx minus 2. So that means what I can write the equation 1. Equation 1 can be expressed as 1 by 3, 1 implies. The equation 1 gives 1 by 3 into, this is dt by dx minus 2. So this is all replaced by dy by dx. On the right hand side, it will be 2t plus 5 by t plus 4. So then this equation. So on multiplying, 3 multiplying on right side, dt by dx is equal to 3 2s are 6t plus 3 5s are 15 by t plus 4, and minus 2 on writing right side you will get plus 2. So now on taking LCM, 6t plus 4 is the LCM, and here 6t plus 2t, that is 8t plus 15 plus 8. What is 15 plus 8? That is 23, which is dt by dx. So the entire problem dy by dx is equal to function of x and y converted in terms of the function of t and x terms only. Now you can apply the variable separable method. So you can apply variable separable method on separating the variables. So what I can write here, t plus 4 by 8t plus 23 dt is equal to dx. On separating the variables, on writing the dt side, the t terms, you will get t plus 4 by 8t plus 23 dt is equal to dx. On integrating both sides, you will get the required solution. So on integrating, what you will get? Integral t plus 4 by 8t plus 23 dt is equal to integral dx plus c. So how you will find the integral on the left hand side? In right side, no problem. Integral dx is x plus c is same as c. But on the left hand side, we have integral t plus 4 by 8t plus 23 of dt. So this I will solve by using just, you see, integral t plus 4 by, I'll see, 8t plus 23 of dt is equal to integral dx plus c. Now to evaluate the integral, I multiply and divide with 8. Multiply and divide with 8. Then you get 1 by 8 into 8t plus 32 by 8t plus 23 of dt is equal to x plus c. Just I have multiplied 8 in the numerator and denominator. So 1 by 8 into, so now I can rewrite the numerator part 8t plus 23 plus 9. That means 23 plus 9 is remains same, 32 by 8t plus 23 of dt is equal to x plus c. Now on separating into two terms, 1 by 8 into integral, first term 8t plus 23 by 8t plus 23, that is 1 into dt, plus the second term 9 by 8t plus 23 of dt. On the right hand side it is x plus c. So this is equal to 1 by 8 into integral dt, that is equal to t. So here 9 by 8 into, I can rewrite this as 8 by 8t plus 23 of dt is equal to x plus c. Just for our convenience, I am taking 9 outside and divide by 8 and multiply it by 8. Then 1 by 8 into t plus 9 by 8 into, so this is looking like f dash of t by f of t. So on differentiating in the denominator 8t plus 23, you will get 8 that will appearing in the numerator. So this is looking like integral f dash of t by f of t dt. The formula is log of f of t, log modulus f of t, or you can write it as log of 8t plus 23 on the right side the remains same x plus c. Now what we have to substitute finally? T is equal to, what is T? What is our assumption in the previous slide? What is T? We have taken T is equal to 2x plus 3y. So on substituting T is equal to 2x plus 3y, we will get the final solution. Where T is equal to 2x plus 3y is the required solution. So the solution is 1 by 8 into T means 2x plus 3y plus 9 by 8 into logarithm of 8 into again 2x plus 3y plus 23 is equal to x plus c. So this is the way of solving the non-homogeneous differential equation. So to solve the non-homogeneous differential equations, we have to check the value whether a1 b2 minus a2 b1 not equal to 0 or is equal to 0. If it's equal to 0, we follow one procedure. If not equal to 0, we follow the other procedure. So far we have seen three methods. The first one is variable separable form to solve the first order and first degree differential equation. To solve the first order and first degree differential equation, we have seen three methods. First method is variable separable forms. That is very easy method. By separating the variables and integrating, you'll get the solution. In the second method, we have seen homogeneous differential equations. If the given differential equation is in the form of homogeneous differential equation, we take y is equal to vx substitution. Thereafter, the total equation reduces to the form variable separable form, and then we integrate easily. And the third method already we have seen is non-homogeneous differential equation. So if the given equation is a non-homogeneous, then based on the condition a1 b2 minus a2 b1 0 not equal to 0, we solve the given problem. The next method is exact equations. Suppose if the given differential equation is exact equation. So what is the exact equation? Exact equation means a differential equation is said to be an exact differential equation if it is obtained from its primitive by mere differentiation and no further operations are used. Suppose if you take the example xy is equal to constant. Xy is equal to constant. So on differentiating, what you will get? On differentiating xy is equal to constant, if you take on differentiating x treating as constant, dy derivative plus xy into dx is equal to constant derivative 0. Clearly, this is equal to 0. X dx plus y dy, x dy plus y dx is equal to 0 is the differential equation because it is containing dy and dx and all are first order and first degree. So it is a first order and first degree differential equation. Clearly, it is obtained from the original function xy is equal to c by direct differentiation and no further operations are applied. So we call this as an exact differential equation. So how to check the exact differential equation? How to check the exact differential equation, whether the given equation is exact or not. So how you cannot observe whether it is coming primitive directly or not. That observation is very much complex. So that we have one condition for exactness. Suppose if the given equation is in the form mdx plus ndy is equal to 0. Is the given differential equation where m and n are functions of x. The given equation is in the form mdx plus ndy 0, where m and n are functions of x and y, having the continuous partial derivatives in a particular domain D. That means there exist a partial derivatives for both functions m and n. Then the differential equation is said to be exact if it satisfies the condition dou my by dou is equal to dou n by dou x. Dou m by dou y is equal to dou n by dou x. So what is dou m by dou y? Dou m by dou y means partial derivative of m with respect to y. That means when you are doing partial derivative with respect to y, x terms treat as constant. Similarly, to find dou n by dou x, when you are differentiating partially with respect to n, treat y terms as constant and do the integration. Very simple. Suppose if the given equation is obtained from its primitive only, then its differential equation is said to be exact equation. So to check whether the given equation is exact or not, we see the condition. If the given equation is in the notation m dx plus n dy is equal to 0, then where m and n are functions of x and y, and m and n are having continuous partial derivatives in the particular domain D, then the differential equation is said to be exact if and only if dou m by dou y is equal to dou n by dou x. So how to find dou m by dou y, I will see in the example. So what is the case if the condition is exact differential equation, then what its a solution? Solution also we can see here. The solution of exact differential equation is integral m dx, treat y as constant, plus integral the terms of n not containing x terms into dy is equal to c. Clear? If the given equation is exact equation, then writing solution is very easy. We have a particular format, that is integral m dx treating y as constant, y terms as constant terms, plus integral the terms of n not containing x terms. You have to take only the x y terms only in the second integral is equal to c is the required solution. So I can write the solution of, so if m dx plus n dy is equal to 0 is the given differential equation, first we have to check whether dou m by dou y is equal to dou n by dou x or not. If dou m by dou y is equal to dou n by dou x, the equation is said to be exact equation. If it is exact what? Then you can write the solution easily. Integral m dx plus integral the terms of n not containing x terms into dy is equal to c. So in the second integral, we have to write only the y terms only. If there is any x term, we have to omit that. So in this way, the solution will be for the exact differential equation. So you have to remember that the condition for exactness is dou m by dou y is equal to dou n by dou x. If the condition satisfies, the equation is said to be exact. Otherwise not exact. If it is not exact, then we go for another methods, which is the non-exact differential equation solution methods. So that is another topic after completing of this. Then we see some examples how to solve the exact differential equations. So the given differential equation here, y square minus x square dx plus 2xy dy is equal to 0. So first you have to check whether the given differential equation is obtained from its primitive or not. So that can be done by using the condition for exactness checking. So here this is the given equation in the form m dx plus n dy is equal to 0. Already it is in the form. So here m is y square minus x square and n is equal to 2xy. Then what is dou m by dou y? We have to see dou m by dou y. Dou m by dou y means the partial derivative of m with respect to y. So with respect to y, when you are doing x terms as constants and the second term derivative is 0, only you will get 2y. When you are differentiating partially with respect to y, the x terms treat as constant terms. X square entire term will be constant. The derivative of that is 0. And what is dou n by dou x? Here we check the another partial derivative value. Dou n by dou x. When you are doing partial derivative with respect to x, y treat as constant, that is 2y constant, x derivative 1. So this is equal to 2y. So then what is the condition? Dou m by dou y and dou n by dou x both are same. That means what? The equation is an exact differential equation. So when the equation is exact, then you can write the solution easily. How to write the solution? The general solution will be integral m dx, treating y as constant, plus integral the terms of n not containing x terms into dy is equal to c. So first you have to check the condition of exactness. If it is exact, then we go for the solution integral m dx plus integral the terms of n not containing x terms, the terms of n not containing x terms into dy is equal to c. So what is here m? Integral m not dou m by dou y square minus x square dx, integral m dx plus integral the terms of n not containing x terms. So there is only one term in n and which is containing x. So this is 0 into dy is equal to c. So what is the integration? Here when you are integrating with respect to x, treat y as constant. So y square derivative integration y square into integral dx minus integral x square dx is equal to c. When you are differentiating with respect to x, treat y as constant as per our solution method. So here treat this is taking y as constant. So this is y constant, then y square right outside integral dx. So y square x minus x square integration x cube by 3 x power n plus 1 by n plus 1. So the solution is integral y square x minus x cube by 3 is equal to c, which is the required solution of the given differential equation. It is somewhat compact method. So when you compared with the this is homogeneous equation also. This is homogeneous equation also. This is 2 degree. This is also 2 degree. So by taking y is equal to bx, you can solve the equation. But it is the very lengthy method. So instead of using that homogeneous differential equation method, we can go for the exact differential equation method. So here you have to check the condition for exactness. Dou m by dou y is equal to dou n by dou x or not. So this is the condition, dou m by dou y is equal to dou n by dou x. So if it is satisfies, the equation is said to be exact equation. Now we see some another problem. Solve e power y plus 1 of cos x dx plus e power y sin x dy is equal to 0. So first we have to check whether it is the exact equation or not. And before that, you have to write the equation in the form m dx plus n dy is equal to 0. Clearly, it is in this form, m dx plus n dy is equal to 0. And what is here? M is e power y plus 1 of cos x. And what is n here? E power y into sin x. So this is m is, I can write e power y cos x plus cos x, and n is same as e power y sin x. Then what is dou m by dou y? The partial derivative of m with respect to y. So with respect to y, x term is constant, second term 0. No derivative here, it is 0 simply because it is a constant derivative 0. So e power y derivative e power y and cos x treat as constant. Cos x treat as constant. So so e power y into cos x is the dou m by dou y value. Then what is dou n by dou x? Dou n by dou x. That means what? The partial derivative of n with respect to x. So when you are doing partial derivative with respect to x, treat y term is constant. So e power y, write e power y as it is, and sin x derivative with respect to x cos x. So this is e power y cos x and this is also e power y cos x. So then what is here? What we have obtained is dou m by dou y is equal to dou n by dou x. So the equation is an exact equation. So when the equation is exact equation, then we can write the solution as, what is the solution, general solution? Integral m dx, treating y as constant term, plus integral the terms of n not containing x terms into dy is equal to c. So what is m here? What is m here? E power y cos x dx first term plus integral cos x dx, no change. So treating y as constant term, cos x is cos x, plus, so the term, in the term n, there is x term also. So the terms of n not containing x terms. So this is integral 0 into dy is equal to c. There is no terms from n side because n containing the x term. So we should omit the term. So integral 0 dy is equal to c. Now what is the integration? So e power y cos x dx. So what is the integration? When you are doing integration with respect to x, e power y is constant, e power y. And what is other term? Integral cos x dx. Integral cos x is sin x. Am I right? Plus integral cos x, that is sin x. Integral cos x is sin x. So plus 0y is equal to c, or e power y plus 1 of sin x is equal to c. Am I right or not? So suppose if you observe that, on differentiating this, you will get this one or not. E power y plus 1 treat as constant term, sin x derivative cos x dx, first term, plus e power y plus 1 derivative, e power y plus 1 derivative, e power y dy, sin x treat as constant, sin x is equal to 0. This is obtaining this equation by direct differentiation or not. So this is the primitive and this is the differential equation. The differential equation is obtained from its primitive, from its original function or from its solution by direct differentiation. That equation is said to be exact equation. If it is exact equation, then you can write the solution as integral m dx plus integral the terms of n not containing x terms into dy is equal to c. So this is the method of way of solving the exact differential equations, and we will see some examples also. Here also one example. What is that? 2xy. Just I will check it out whether it is exact or not. 2xy minus 3x square of dx plus x square minus 2y of dy is equal to 0. This is the given equation. So what is it? Is in the clearly in the form m dx plus n dy. So m is what is 2xy minus 3x square. And what is n? X square minus 2y. Then what is dou m by dou y? Dou m by dou y means partial derivative of m with respect to y, because we are going to check the condition for exactness. So with respect to y means x constant. So the first term 2x and this is 0. 3x square is constant term when with respect to y. Then what is dou n by dou x? Dou n by dou x, first term 2x and second term is 0. So these two are equal. So the condition of the exactness satisfied. So the given equation is exact equation. If the given equation is exact, then what is the solution? Thus, what is the solution? Integral m dx. M dx means 2xy minus 3x square of dx plus integral the terms of n not containing x terms. Not containing x terms. This I have to omit. The remaining term minus 2y dy has to be present is equal to c. This is in the bracket. Minus 2y dy is equal to c. So clearly here in the term n there is one x term and one y term. Pure x and pure y terms. So on omitting the x term, the terms of n not containing x terms. So x term we have to omit. So the only term of y is minus 2y into dy is equal to c. Now on integrating with respect to x, we are treating y as constant, 2x square by 2 into y minus 3x square integration, 3x cube by 3 minus 2y square by 2 is equal to c, or 2 to cancel. This is minus x square y minus x square y minus x cube minus y square is equal to c. So which is the solution of the given differential equation. So this will be considered as an example, and you do as own cos y dx plus y square minus x sin y dy is equal to 0. Here what is m? So in this problem we can take what is m here. M is cos y, and what is n? Y square minus x sin y. Then dou m by dou y, the partial derivative with respect to y minus sin y. Dou n by dou x, this is 0, this is 1 minus sin y. So both are same. That means it is also exact equation, and it will be leave as the homework of this problem. Okay. So in the next class, we will see the non-homogeneous, non-exact equations. So far we have seen exact differential equation, how to solve the exact equation. We have very simple method. We have condition for exactness. If dou m by dou y is equal to dou n by dou x, the given equation is an exact equation. If it is exact, then write the solution integral m dx treating y as constant plus integral the terms of n not containing x terms into dy is equal to c. Suppose if the equation fails, condition fails, if the equation is not an exact equation, that means what? If dou m by dou y is not equal to dou n by dou x, then the condition for exactness fails. That means the given equation is not an exact equation. So in that case, what we have to do, that will be discussed in the next class. So these are the few topics which I want to discuss in this video. So thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.